for this boy. Before you start, obviously everybody knows how to turn it on, right? Cool. I'm sorry, I'm starting with from the beginning. Turn it on. The most important thing is, like everything else, garbage in, garbage out. Very, very important before you start. When you start anything, can you guys look with three-phase 60? Can you guys see three-phase 60? That's the temperature, and CU for copper. Anything you do right now, conductor-wise, it's taking into consideration three-phase, and it's copper and 60 degree, 60 column. Would that screw you up really big when you start sizing based on 75? Okay, that's the most important thing. Every time you turn around, look at this. That's three-phase, 60 degree temperature Celsius, and copper. Okay, how do you change this? Suppose I want to change it. So you see where it says set here? Click on set and hit 7. See underneath it says CUAL aluminum. Set 7. Where did it? Why didn't that go? I'm sorry? Is your buttons, is it completely different than yours, guys? Set, thank you. The number is above it, yeah. So set number 4. Can you guys see it change to aluminum? Can everybody give me a thumbs up? We know how to change it to aluminum. Let's go back and change it to set number 4. Is yours also set number 4, guys? Right? Set number 4, change it into copper. Can you guys do that? Aluminum cover. Thumbs up, chat. We know how to change aluminum cover. Very important before you start. Next, phase. So let's go where the one it says. So can you say set number 1? That will give it phase. Can you guys see that? And set number 3, that'll get you 3-phase. Can I have thumbs up, chat? We know how to do single phase or 3-phase before we even start. Okay, so these are copper and aluminum and single phase. 75, set 75, 60. If you go set 75, set 60, where's 60? 9 or 6, thank you. Set 60 will give you 60, set 7 will give you 75, and set 9 will give you 90. Can I have thumbs up, Chad? So here's my warning for you. We're going to use this for commercial. Always make, when you do it for commercial, always make sure that your calculator is set for copper. So go back and set it for copper. If it's not copper, and make sure it's set for 75. Set 75, and make sure it's set 3-phase. That's your default because you're using it for commercial, right? Typically. So that's your. I like this to be my default. Copper 75. That's my default. Cool. Everybody's okay with this? All right. So that's now. Every time you guys go hit twice on C, hit it twice every time you finish an operation. Always. It deletes the memory. See what on here? Hit it twice. Okay, let's go work on this one. So suppose I have this scenario. I have a panel, and here's my load. And suppose I have a 200 amp panel, right? I have 200 amp panel, and I need to size the feeder. Okay, here's the scenario they have. 200 amp, we're going to size the feeder for a 200 amp panel. It's 3-phase. Let's do it's a 3-phase, and it's 3-phase, and it's CU, always copper. We're going to size the feeder to feed this panel, 200 amp. Cool? Everybody's okay with this? Let's go do it. So let's go. So first of all, you need to do the amps. So hit 20. They'll type 20020. Everybody had 20020. I mean 200. Type 200 basically. Okay. And type amps. Where it says amps. Hit amps. So I have 200 amps now. I have 200 amps. Now, if you hit wire size, it'll get you 3-aught copper. See where it says wire size? Now I have just size a 3-aught conductor. Can you guys verify that one? 3-aught will go to 200 amps. Copper at 75. Remember, it's 75. Can I have thumbs up, Chad? So how easy that is? Okay, take another. Now we're done. Hit on C at least 2 times. That button at least 2 times to clear the whole thing. Now take this. I have a 400 amp panel. 400. 400 amp panel. So you're going to hit 400 and hit amps because these are amps. Can you guys see it? It shows amps here. So I have a 400 amp, 3-phase, 75 copper system. I need to size the conductor for it. So what do you hit? Hit wire, 600 kcm Cu. Hit wire again. Hit wire again. It'll give you 420 amps. This is how much current this 600 kcm can carry. 420. And I need only what? 400. Hit the wire again. It will tell you the kcm for the wire. Hit wire size again, it will tell you which table that this is coming from. 310.16. They haven't, did they update yours to 310.15b16? Yeah. Suckers. They haven't updated that one. Now I'm jealous. Hit wire again, it will take you back. Can I get you guys, see, you keep hitting the same wire, it gets you different things all the way to the code. Can I have thumbs up, chat? Cool. Now let's take it more exciting. So that's how you size the wire. Now take this. Go clean. Make sure you clean. Every time you change, you do anything, clean again. That will erase everything that you've done before. Always, when you finish an operation, clean. Hit C twice to clean the operation. Thumbs up, Chad? Cool. So let's, and if you hit set, I don't know if you guys, if you hit set and X, this is will clear all you, no, this is mine is set based on 2008. That's why. Is yours guys hit set and X. What, are you 2011? Okay, that's why. That's why. So I know that set, there's a place now, preference. No, cancel. Let's see, set references. That's not giving me, how the heck? Set divide, where's my set? Yeah, that's what I'm hitting, set and divide. Give me 2008. Say, or maybe set divide again. How the heck did I change it last time? There's a way where, okay, clean, clean, clean. That's why. Set. Yeah, that's what I was going to say. Plus. You don't have it there. I don't have it. You son of banana. I had it. Okay, I just want to order the one that has 2011. Well, it's really there's no change other than the names, guys. Take this. So let's say a continuous load. Let's say a heater. So let's go change this one into a heater, right? So I have a heater. This is a heater. And I bought the heater. I bought my heater as, let's just say it was 30 amps. I have a 30 amp heater. Now, is the heater continuous load or no? Okay, that's where I'm going to go. So here's my question for you. I have a 30 amp heater, 3-phase. So I'm going to go set my terminations. My terminations. Do you guys hear me? So let's say it's 3-phase. This heater is 3-phase. I want to put my termination to 3-phase. So set 3-phase. I'm set for 3-phase, and I need to set 75. Okay. So if I have a heater, 3-phase stuff, guys, almost always rated for 75. So you can go. So I have a heater rated for 75 logs. It's 30 amps, and I need just to size a conductor for it. Continuous load. Look what you do. Hit 30 and hit amps. Right? Everybody 30 amps. Now, since it's continuous load, you're going to do one step different. You're going to hit set. See what it says here, set. And hit the wire. It will size it based on 125% of that number. Can I have thumbs up, Chad? It sizes it based on 125% of that number. We didn't do this for the panel because the panel, we match it to the overcap protection device. But if you have a load that's continuous load, like motors, or you put the amps and put set wire size, it's sized based on 125, not just based on 100%. Can I have thumbs up, Chad? All right, so again, clear it. Clear it. Let's go one more time. Let's say I have a machine an HVAC machine, and the machine was pulling 120 amp. Can you guys put 120 amp? 120 and hit amps. Cool. 120 amp machine, three phase, and because continuous, I'm going to go set and wire size. So the size is 0 copper. Hit the first one. Here's how much KCM is that is. Hit again. Here's your KCM. Hit the table 310.15b16 and hit the size. Here's the size. The second hit will give you the amp that this size can handle, and the second one will get you the KCM. Remember that KCM? And the third one will give you the table. Everybody can go there. See how nice that is? All right, now we know how to do the wires. That's it in terms of amps. Let's switch to another very important thing. You guys are going to do motors with your friend Chad. Motors. Let's do motor calculation on that sucker. Motors. For cables, very easy, guys. You put the amps and size it. Motors. Okay, so let's put an example of a motor example here for you, and then we'll do a couple of things here for motors. Really cool. So suppose I have a 50 horsepower, the voltage, and I need for motors we need a circuit breaker, and we need a disconnect. I have a disconnect, and I need an overload. See how? So I have circuit breaker, I have an overload condition, and I have a disconnect. So this is circuit breaker, this is disconnect, this is overload. Everybody knows that motors, they have all these systems in it, and this is the conductor. Here is conductor. Okay, so let's go size this. What's the voltage system? Anybody give me a voltage system? 480. 480. So this is a 480 volt, and it's three-phase, of course. Okay, so I have a three-phase 480 50 horsepower motor. And what do I need to do? I need to size the circuit breaker, the disconnect, the overload, and the conductor right from the calculator. You're going to do this tomorrow with Chad by hand. So let's do it. So first of all, make sure you're set for three-phase 75 copper. Everybody set that? Click on the delete. Make sure this is your calculator set this way. Cool. All right. So start with the voltage. You can start anywhere you want, but let's start with the voltage. Here's my 480. And do you see where it says volt? Hit volt. Make sure you type 480 and hit volt. Now your voltage is what? You have just told the calculator that everything I do now, make sure you use a 480. Can I have thumbs up, Chad? Okay, the voltage. All right, what else do we need? A three-phase, it's already set for three-phase. I need the horsepower. It's already set for three-phase. I put the voltage, I need the horsepower. Okay, what's the horsepower? Type 50. You don't have to erase what you did, just type 50. When I put the voltage, I didn't erase, just hit the voltage and then type again. It goes to 50. Do you guys see where it says horsepower here? Click on this particular horsepower, horsepower motors. I'll tell you the difference between horsepower, this one and this one. This is the one I'm going to use. Can you see that one horsepower motor? Click on it. You have just told the system that you have an induction motor, which is 99% of your motors. Can you guys see I and D? This is induction motor. That's 90% of your motors are induction. We can change it to synchronous or DC. 90% is defaulted to induction. So I have a 50 horsepower induction. Can I have thumbs up, Chair? Cool. Now, that's it. That's all what you need to do, the horsepower and the voltage. Everybody put that one? Now, let's see what's the full load amp for this motor from the NEC code book. Now, just the full load amp. Okay, can you guys hit amp here? This is 65 amps. If you go to the table 430.52, it will tell you 65. Now, it gets easier. Hit the amps again. Oops, it doesn't take you to the, does it take you guys to the table? Okay, so 65, this is coming from the code. Can I have thumbs up, Chad? 65. Okay, now, since it's a motor, when we size conductor, guys, just hit it. You don't have to type anything. When you size conductor for motors, continuous load. So what do? Hit set and wire size. Here's the 4 copper that you're going to do for this conductor, for this. Set copper wire size. Can I have thumbs up, Chad? Here's a conductor. How many conductors? 3. Why 3? 3-phase. And the size is 4 copper. Now, if you hit the wire again, it will give you 85 amps. It's good for 85 amps. Here's the circular mill. Here's the table. And it takes you back to copper.
Where it says the 85 amps and it says a 4, does that mean you need 4 conductors?
I think it's taking into consideration the yeah, but it for good point. Yeah, I think it's 3-phase plus the neutral, but I'm not sure about that. That what 4 here. But this is clear, circular mill, right? Clear in that one. And you see the gauge for 485. I think it's you're right, but we don't pull a neutral with motors. Yeah. It doesn't really make the difference though. In this case, it's not going to make a difference in the way we size them. I'll check on that one. Okay, so here's conductor. Now it gets even nicer. Cool. So don't hit the erase in any way, shape, or form. Now let's go size. Am I using a circuit breaker? Let's go size a circuit breaker. Can you guys see with this one? It says inverse time. Everybody can see that? That's an inverse time circuit breaker. Hit this one. It gives you a circuit breaker 162.5 circuit breaker. Now all of us know that there is no 162.5. So what are you going to go? Up to the next standard. It doesn't tell you the standard. You have to go pick the standard. The next standard is what? 175. Change your mind because you're anti-circuit breakers. I don't want circuit breaker, Chad. Change your mind, right? I want a fuse. So can you guys see where it says dual element time delay fuse right here, right next to it? Click on this. It'll get you the fuse. That's the fuse size. If you click again, it will tell you what the percentage that they're calculating at, 175. If you click again, it will tell you which table did it go to, 430.52. One more time. And it tells you what here's the fuse size. Then the second click will give you the percentage that they size there. Third click will give you the NEC code book, and you go back to the fuse size. So 113.75, what's the next standard? 125. If you don't know, where would you go? 240.6. Cool? Now Jeff, because he's troublesome truck, he said, Chad, I don't like dual element time delay fuse or circuit breakers. I need the standard fuse, non-dual element, the other one, as fuse. These are non-time delay fuse. Hit set. Can you guys see where it says set? And hit the fuse again. It will size the fuse based on the 300% non-time delay fuse. And if you click it over, it tells you how it sized it. Can you guys see? Keep click on it. Here's a 300 now. Can I have thumbs up, Chad? See how nice that is? You can size all the fuses. Now, it gets cool. Let's go hit overload. Hit overload. Here's the size of the overload that you're going to have. 74.75. You hit the overload again, it's sizing it at based on 115. Typically, 115 is a default. There's some exceptions. You hit again, it will tell you where in the NEC code book it tells you there, 430.32. Does that make sense, guys? If you hit it again, give you the size. That's the overload. You're going to do that with Chad tomorrow. Overload. Okay, what else do we have? Starter. Can you guys see where it says starter? NEMA starter. Hit set and go to the motor. You need NEMA starter 3. If anybody knows what the NEMA starter is? The size of the starters, right? Later, not this project, next project, when you guys size, you're going to be sizing NEMAs for me. I wouldn't accept other than NEMA. NEMA, it will get you the size of a contactor and the overload with it. So I need NEMA 3. Does that make sense? So from just the voltage and the horsepower, I got the NEMA starter, and I got the fuse or circuit breaker, and I got the overload. Okay, so that's, I think magnetic type, none. I don't know what magnetic type, I forgot. Okay, why don't you guys go erase everything, go on C. If you want to get rid of everything that you inputted, you hit the on C 2 times, at least 2 times. It gets rid of everything in the memory. Okay, does that make sense, guys, for horsepower? Let's do one for single phase. Single phase because we're single phase. Let's go first set the calculator for single phase. Set 1. I have single phase. Since we're doing single phase and we're going to use Romex, I'm going to set my calculator to 60. So set your calculator set 60. Everybody's calculator set single phase 60, copper. I love copper, so I'm going to leave the copper as is. Okay, so let's take 10 horsepower. Cool, everybody, 10 horsepower. Here's 10, type 10 and hit the horsepower, 10 horsepower. What voltage system single phase do you guys want? Typically 240. You can't find them at less than 240 these. So here's my 240 and hit voltage. That's all what you need to do. The voltage, 240, hit volt, and 10 hit horsepower. Everybody's done with that? Okay, let's go find what's the full load amp for this boy. 50 amps. Just hit amps. 50 amps. Did you guys get 50 amps? Okay, now I need to size the conductor. Continuous load. So you have to hit the word set and hit wire size. Here's the conductor size. Based on what? Based on 60-degree column. Now, since they're motors, you can size based on 70. So if you want to size on 70, what do? Just go change it to 70, 75. Okay, I need the circuit breaker. Hit the circuit breaker. Here's the size of the circuit breaker, 125. I need a fuse. Here's the fuse size. I need an overload. Here's the overload size. I need a NEMA. Set NEMA. None. They don't make him at the single phase at this size, I guess. There's no way it's giving you none. There's nothing for this particular size. Okay? Can I have thumbs up? We know how the motors, guys, for the most part. All right. The single most important about this is conduit fail. Let's do conduit fail. Shall we do a conduit fail? Okay. Here's the example that I'm going to do conduit fail. So we did ambiguity, we did motors. Let's do conduit fail. Let me take this example for conduit fail. I have a big fat fluffy conduit and I need to size 1, 2, 3, 4, 5, 6. Let's just say I have 25 number 10 AWGTHHN in a conduit, and I need to use EMT and PVC. I want to size a conduit that can carry all these conductors, and first I want to try the EMT, and second I'm going to try the PVC. Okay, so 25. Here's how we do it. Let's start with the size of the conductor. What size conductor do we have? 10. First of all, make sure you clear it. Can you guys clear your calculator by hitting the red button twice? Okay, so the conductors are 10. Type 10. Everybody type 10. And do you see where it says wire size? Hit wire size. You have just told the calculator that the wire size that you want is number 10. Do you see how now wire size flipped? The function of wire size? Any one of these buttons can be input or output, guys. Okay, so here's number 10, copper. And it defaults to copper, by the way. Okay, now number 10, that's the first thing. How many conductors do I have? 25. So type 25, 25. And do you guys see the insulations here? The insulations. Do you see THHN? First type 25 and then hit THHN. You have just told the calculator, I want you to accommodate for 25 THHN conductors. Each one of them is number 10. Cool? Everybody's okay? Now hit the conduit. Do you see conduit here, guys? Hit conduit. Your EMT conduit, it defaults to EMTOs. Your EMT conduit, can you guys see at the top, is 1.25 inch. Everybody got that one? Now I don't want it, Chad. I want, if you guys look at the back of the calculator, it has how to flip them. If you hit set conduit, I need PVC. Can you guys see at the top, sitting conduit? It says sit conduit, what the heck is it, where's the PVC? Let's do schedule 80. Everybody can see that set conduit 9 will give you 90. So here's what I'm going to do. I'm going to hit set conduit and 9. You
gotta hit 9 set in the conduit.
Okay. Enter the number and press set. Oh, now you have to go 9 set conduit. We did it the wrong way. Okay, 9 set conduit.
You can cycle through them manually too.
And you can, yeah, and you can manually, absolutely. So let me just go one more time, guys. Here's my 10 conductors, wires, and there's 25 of them because I deleted my stuff. Here's 25, and here's my conduit, PVC. If I want to change it into EMT again, I'm going to hit 1, set, conduit. Here's my EMT size. If you want to change it into IMC here says 4. You're going to hit 4, set, conduit, or like my friend said, Jeff, he'd say you can cycle through them, Chad, by hitting, and if you hit, look at this, if you continue hitting it, it will tell you the fill. Look how nice it is. So here's IMC, here's the fill, 32% filling. Here's the cubic, what would that be? The cubic inch, the area, the cubic, not cubic inches, the square inches occupied in it. So all these will get you there. If you want to circulate it through them, you just hit set and it keeps circulating through all the sizes that you have, the available sizes. A faster way, guys, is to use the back of this calculator. Can I have thumbs up? Chad, we know how to do that. Now let's complicate the situation and then let you go. Let's add to these conductors, let's add another set of conductors that are different. I have another 20 conductors, number 12. A, W, G, T, H, H, M. Now we have two sets of conductors, different conductors. I have 25 of 10 and 20 of 12. Cool? Let's do that. So the same, go clean your calculator first. By the way, when you do conduit fill, it really doesn't matter if it's single phase here. The conduit fill doesn't matter here. Okay, so let's start with number 10. I have start number 10. Here's 10 wire size. Can you guys give me a thumbs up when you're there? Then, how many of number 10 I have? I have 25. 25. And what's the insulation? THHN. Hit THHN. Do you guys get THHN 25? Here's a tricky one. Hit that thing again. Hit it again. Make sure you get the actual size of these conductors all together. That will give you the square inch of all these 25 conductors, number 10 all together. Everybody got that one? Now you're done with the 10, 25, 10. Now next, you're going to go to the 12. You're going to hit 12. Wire size. Now we move to the 12, right? How many of the 12 do we have? I have 20. Hit 20. What type of insulation? Chad used the same insulation. Otherwise, you can go any of these insulations. Hit this one. So it'll give you, here's the 20. Hit that again. It will give you guys the cubic, the square inch for all these 20 conductors, number 12. And before them, we had the 25, number 10. Now you're done. At this point, you're going to go to the conduit. Hit your conduit. Here's your conduit type. Now I don't want liquid type flexible metallic conduit. I need EMT. So I hit 1, set, and conduit. That will get me an inch and a half. Did we do it right? Inch and a half. Let me do it one more time because this gets tricky. When you have different sizes, here's how you do it, guys. First, you start with the first size. What's the first size? 10. And hit the wire size. You should see AWG 10. Then, how many of them do you have? 25. Here's 25. What insulation? THHN. When you see the THHN, Andrew, hit the THHN again. You should see the square inches. Now you're done with the first set. Let's go to the second set. The second set was 12. Here's number 12, wire size, okay? Now, how many of number 12 do I have? I have 20, so you're gonna hit 20, and THHN. When you see the 20 THHN, hit the THHN again. It'll give you the square inch for the THHN, okay? Now you're done. You're gonna go to the conduit, You're gonna go to the conduit, hit conduit. It will give you an inch and a half. Now, change your mind. You want a PVC schedule 40? What's PVC schedule 40? It says 10. So I'm going to go 10, set, conduit. Here's PVC schedule 40, an inch and a half. Any question, guys? So these are the most important things that you're going to be doing. As you move forward, I will introduce you for a very important concept, guys, still. There's a voltage drop calculation here. There's voltage drop calculation. There's equipment grounding conductor and bonding conductor. Can you guys see that? Equipment grounding conductor, bonding conductor. If you're with Mr. Ryman, you could do parallel series circuit here too.
Is this through box fill too?
Box fill, no. Up to my knowledge anyway. Last time I checked, no box fill. Okay. Any question, guys? Is that enough to get you kind of the juice running? Okay. Thank you.
When you're doing the multiple wire sizes, do you have to get the insulation type twice there?
Yes. Only if you're doing different sizes.
Because if I did, then it came up with the same answer.
Yeah. And you didn't hit the first time. The second set of sizes or the first set of sizes? I believe the second.
I went 10 for the wire size.